Hi, everybody. I'm not going to have my camera on for the full time, but I'm just kind of giving you a really brief introduction before we jump into it about how you should be studying and like going through these. So for every module, so like we have, unit one is 1.1, 1.2, 1.3. I'm going to um, refer to the textbook. We are going to use the textbook for it. Now, you don't have this yet, nor will you have it for about a week, for about 2 to 3 weeks. Check your emails for information about that coming soon. So, in the meantime, you do have to refer to the actual digital file, which I have included in the introduction. But I also want to mimic here about how you're supposed to take these notes because you're not going to be able to write in this thing, nor is there a lot of space. And sometimes it needs some extra information. So you will occasionally, as you watch these videos, you're going to have to pause it to quickly write stuff down and then unpause it, okay? You shouldn't just the videos that you're going to see throughout the next 5 months should not just be played from start to finish. That's it. Not taking any notes, not pausing it. You need to be pausing it. You need to be writing stuff down. If you do not like how I teach it, you can refer to Mr. Mathwell. He's using the same textbook. He's doing things a little different where he will sometimes put this stuff in like a PowerPoint and do it there. What I'm doing is, if you can see on the right side here, I have an example of here's loose leaf. This is paper. This is what you're going to be writing on for a while. And I'm going to be trying to mimic those skills about how you can turn information from a textbook into here's the important parts in a actual piece of paper. And then you use that for your workbook. There will also be a digital file about this. You don't have this yet, nor will you for a bit. So that will be on the front page, but it's also going to be linked down below in week one and week two and probably week three as well. After week three, you should have your books for sure. Check your college emails every couple days. With that said, I'm just going to jump straight into it here. I'm going to turn off my video. So starting out here, the first two chapters are going to be really, really chill. We're talking about money. So we're talking about investing money here. So, if we have someone here, for example, they are traveling to different parts, they need to save money to be able to do that. And sometimes you can earn interest with this. Now, this interest here is where our primary goal is today. We are learning about interest. Simply speaking, if I borrow money from a bank to buy a car, let's say I borrow $10,000, I might have to give them $11,000 back, right? For the privilege of borrowing money. If I put my money into a savings account, I give the bank money, I give them $10,000, they might give me $500 after a year. That's my fee for the privilege of giving them money to lend. So what we're talking about here is we are talking about interest. So what you should be doing here is you should be reading the side panel stuff. Look at the left, look at the right. Don't just zombify, stare at it. Really take a good hard look at the textbook as you go through it. So you can see here we have a couple of highlighted things. What's a term? What's an interest? What's a fixed interest rate? What's a principal? These are all things that you should be including in here. So you should literally be, not that. Here, let me do this. Screenshot. I don't have to write it. You guys do though. So you do want to write these terms down here, right? So a term, again, pause the video, write this down, right? Pause it. Once you're finished, unpause it. 3, 2, 1. So a term is how long the loan is, right? How long the loan is. For example, might be 2 years. The interest is the amount of money that's earned on an investment or paid on a loan, right? So I want to be really clear. This is interest is the dollar figure, right? So we use my previous example. This would be $11,000 charged for a $10,000 loan. What is that? That's $1,000 in interest, right? Now, an interest rate is a percentage. Percentage. Now, one thing I want to note, percent. Per cent. Cent is 100, right? So it's percentage is per 100. So it's per 100. So for example, if I have 5%, that is 5 over 100. Or that as a decimal, that is 0.05. All three of these are the exact same thing. 5% is the same as 5 over 100 is the same as 0.05. One is a percentage, one is a fraction, and one is a decimal. At this point, if you're looking at that and you're not sure, you need to quickly do some research into how to convert between the three of them. That is assumed to be a skill you have at this point. In a different math class, we would spend more time on this. It's assumed you have it at this point. So if you're not as comfortable with math, you have some extra work to do. Now, the principal is the original amount of money. So going into this example here, this $11,000 charged for a $10,000 loan, which one of these is the principal? Well, I originally took out the $10,000 loan, right? That is this part right here. That is how much money I originally borrowed. Okay? So now that we know this, we can jump into the actual textbook, right? Terms are important. So Sierra is 20 years old and needs money to pay for college. When she was born, her parents bought her a $500, notice I'm underlying key figures, Canadian savings bond with a term of 10 years. So they bought a 10-year bond. They chose a CSB as an investment because they liked the security of loaning money to the government. Now, the interest earned, not paid, earned, was determined using a fixed interest rate of 6% per year on the original investment and was paid at the end of each year until Sarah's 10th birthday. So what this means is that $500 is going to go up 6%. What is 6% of $100? Well, that's $6, right? So if 6% of $100 is $6, that much means that 6% of $500 is $30. So after year one, they have, yay, $530. After year two, yay, they have $560, and so on and so forth. What are they going to have at year 10? That's kind of what this is, right? So it's important to understand there's a big difference here between earned and loaned. I gave the government money, they're giving me extra money as a benefit. If I borrow money from somebody, I pay more as that, because you need to have a reward. You don't just give money for free, right? The expectation is I'm going to get some money out of this in the long run. So the question it's asking here is, how can we determine the current value of Sarah's CSB after 10 years? How much interest was paid on the principal by the end of the first year? Well, to do this, we use a pretty simple formula, and I'll explain what all this is. So you can't write down in here. So instead, what I want to do is I want to actually use our notebook, right? We have to learn how to do this on paper. So first off, I missed a key step. This is section 1.1. Ideally, put the page number, guys. You'll save yourself some time. Now, I'm going to be doing question A. How much interest... Sorry, I'm going to write the key figures here, right? So write the page number, write the question. You can refer back to it. Ideally, write down the key things, right? So what we have is we have a $500 CSB bond. The term is 10 years. The interest rate is 6%. What's the question asking? So question A is asking how much interest was earned on the principal by the end of the first year. So it's important you write the question down, or at the very minimum, guys, refer back to it so you can find it. If you just have a bunch of solutions on your page, you haven't helped yourself at all. So you need to keep it organized. So how much interest was earned on the principal at the end of the first year? Well, there's a solution we have for this. So the formula we use is something called I is equal to PRT, or the interest is equal to the principal times the interest rate as a decimal times the time in years. Okay. So important that you guys keep that in play here. Okay, no, I can't. Nope, doesn't let me move that. Oh, well. So key things here. I really want to make note though is it is times. Now, anytime I give you a formula, this is on your formula sheet, but what you do want to do is you do want to put a little square around it. Put a little star beside it. Make it stand out. This stands out now in your notes. When you have 200 pages of notes, this stands out. So interest is equal to the principal times the interest rate times the loan. So all I'm going to do is I'm going to take my formula, I'm going to substitute it in, right? I'm trying to find the interest, so I stays the same. Now interest is equal to the principal. The principal was $500 times the interest rate, 6%. Nope, wrong. Not as a percentage, as a decimal, 0.06 times the amount of time in years. How many years is this? It's a 10-year loan, but I only care about the first year, times 1. Okay? So $500 times 0.06 times 1. I'm not going to show my calculator every single time, but it's helpful to kind of show it. Again, you should have your own calculator here. Use your phone for it if you have to. They're $10 or $5. You could probably just ask someone. They'll give one to you. But 500 times 0.06 times 1, 30 bucks. The interest is $30, okay? Good thing to get into a habit of? Circle your final answer. All right, so that's question A. Now, question B asks us, determine the simple interest earned each year. What is simple interest? Simple interest is the amount earned on an investment or paid on a loan based on the original amount and the simple interest rate. So it wants us to find the simple interest earned each year, the accumulated interest, and the value of the investment for the first 4 years. This is done as a learning tool here. So what you want to do is you want to actually copy that chart into your book. So pause the video, copy that chart. 3, 2, 1. Come on. Paste, you darn thing. Ah, oh. Hold on, I'm figuring this out. Yes, there we go. Okay. And I can move that. Nice. Okay. So what I want to do here is I want to put this in, right? So for the first year, so I start with $500. So the first year here, simple interest earned, I know I earned 30 bucks, right? This was calculated up here. So overall, accumulated interest over time has just been $30. At the end of the year, my investments were 530 bucks, which means at year 2, that's what it starts at. How much do I earn? 30 bucks, right? It's based on the 500. Accumulated interest, well, it's now 60 bucks. And this turns into 560, and so on and so forth. And eventually, your chart should look something like this, right? Really simple. I'm just making 30 bucks a year. So 60 turns to 90. 560 turns to 590. And 590, add another 30, turns to $620, right? So this is just for the first 4 years, right? Oh, I forgot a step. Question B. Cool. So I've done that. Now, question C here asks us, is this simple interest earned each year constant or variable? I don't know what those mean. What does that mean? Well, constant is when it stays the same. You don't have to write this down. Don't write this down if you don't want to. Constant stays the same. Variable changes regularly, usually every year, usually every quarter, but it changes. Changes at a set interval. Now, how much did I make each year? I made 30 bucks. So it stayed the same, right? So for question C here, the simple interest earned each year is constant. I'm not done. Read the question carefully. Explain. So I've said what it is, but why do I think that? This is important. It's important to explain your reasoning. Why do I know it's constant? Because the interest earned every year was $30 no matter what the investment was valued at by the end of the year. Don't think there is a. Yes, okay. So one couple things I want to note here are some terms here. Before we keep going, I want to talk about some terms, which is when is stuff regularly paid? When is this interest paid? Is this interest paid once a year? Just, yeah, okay, December 31st, here you go. Here's your money. So simple interest is accumulated at different rates. Or sorry, not accumulated, is paid out at different rates. So let's say, think about it this way. If it's annually paid out once a year, if it is semi annually, it's paid out twice a year. If it's quarterly, paid out 4 times a year. If it's monthly, well, it's paid every month, right? Everyone kind of gets that one. 12 times per year, right? And then you can do like daily, you can do weekly, stuff like that. I also want to bring up, you might see this term here, bi-weekly. Look at the difference between semi and bi. Okay? Semi, twice per. So semi-weekly would be 2 times a week. Whereas bi means every two. Bi-weekly means every two. These are different. So bi-weekly, well, it's every 2 weeks. How many weeks are in a year? There's 52 weeks in a year. If it's every 2 weeks, divide that by 2, it's 26 times per year, right? And there's more, but if you understand the difference between bi and semi, and you know these other terms, you have it all. Again, important information. Gonna put a little big old square around it, right? You're gonna be referring to this. It's expected you know it. If you've taken financial literacy or math 20 or math 30, you have this information already. All right. So question D here. Describe the relationship between numbers of years. We've already talked about this. This isn't that useful for the sake of this. I do because I do want to try and cut these down. Question E. Use the relationship from part D to determine the investment. Okay, maybe I'm going to combine D and E. D plus E. Right? So relationship between the number of years. Basically, every year the investment gains $30, right? So after 10 years, well, if it's $30 a year, $30 per year means it's $30 times 10 years, means the interest gained was $300, which means the investment after 10 years is equal to the $300 of the loan plus the $500 of the principal. So the entire investment is worth $800 by the end of the year. Now, we do also want to graph something here as well. So graphs are kind of tricky. So with a graph here, there's a couple things you kind of need to know. To freehand it, what you do is you just draw yourself a nice straight line. Let me just adjust the color here. Aha. All right. Do a nice straight. Nope, not that. Sorry, I have some limitations with what I can do on this. Here we go. Make that bolder, actually. Here we go. So with question F, it wants us to graph it wants us to graph the growth of the investment until its maturity, which is the end loan. The loan has matured, it's done, it's grown, it's out of the house, it's gone. Um, at using times and value. So it wants us to actually graph this thing here, okay? So to draw a graph, what makes a good graph? Well, one, it's going to be neat, is that what I'll say. And usually that means like straight lines and stuff. But two, it's going to be labeled. Specifically, the x-axis, the y-axis, the title, and the line. So what is that? Well, x goes left and right. It's the horizon. It's horizontal. Y goes up and down. It's vertical. Also, what it's also going to have here is it is going to be properly scaled. What that means is that it needs to use most of the graph space, use most of the space, and it needs to be easy and consistent intervals. Okay? So easy and consistent intervals. So what does that mean? Let's think about this. How do I find these intervals? Oh, I don't need that. How do I find that? Well, let's think about it this way. I know that the maximum amount of years I need to do is I need 10 years. The maximum amount of money I need is $800, right? So I need 10 years and $800. What that means is I need to go up to 800 at the end of the graph, $800, and I need to go to 10 years at the other end of the graph. Now we usually have time is the x-axis and money is the y-axis. That is almost always going to be the case. There's other things. This isn't a graphing lesson, but basically, okay, I know the time is the x-axis, so I know that this needs to be 10 years here, right? So I'm just going to go, this is 1, here's 2, 3. I'm freehanding it, right? I'm making these about the same distance. They're going to be a little off, but you're trying to keep the distance the same. It shouldn't go like this. This is a mistake. That's wrong. But this is fine. It might be a millimeter off, but we're freehanding it. You're not a computer. 9, and I know it needs to go to 10 years. Now, for the y-axis here, well, I know I need to go up to $800, right? So how many lines do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 16 lines. So if I have an $800, I only have 16 lines to work with. Each of those lines needs to be at least 50. Needs to go up by 50 every single time. Now, let's say I only had 10 lines to work with. Each of these lines would have to be 80. Now, you can do 80. You could also go to an easier number. You could go to 100, for example, right? And I'm actually going to do that. I'm going to use 100 in this case. Let's pretend that this part of it doesn't exist. Is there a way I can erase this? So can I, yeah, so I'm literally going to do this. I'm going to intentionally shorten my graph for this example. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 11 lines here. I have $800. Here's the time in years. Here's the money. So I'm just going to go up by $100 each time. I'm going to make it that simple. Properly. There we go. Right? So here's 100. Here's 200. Here's 300. 400, 500, 600, 700, 800. Yay, right? So I know that for year 1, change the color to Blue. I know for year one, I had $500, right? I went to year one, I went up, went to five over there. That's where it goes. For year two, I had about $530. I'm just going to put it, it's not right in the middle, it's a little bit below. Again, you're just kind of freeballing it as best you can. For year three, I had $560. Sorry, for year three, I ended up with $590. Year zero, so I've already done a mistake, right? Year zero, I had 500. Year one, I had 530. Year two, I had 560. Year three, I had 620, and so on and so forth. I'm just going up $50 every time. By year five, I would have had 650, right? Add $30. So 650. Year six would have been five. Wait, well, I made a mistake. My bad, guys. Um, see, even teachers make mistakes. 530, 530, 560, 590, 620, 650, 680. After year seven, it'll go up to 710. Oops. Year eight, it'll go up to 740. Year nine, it'll go up to 760. Year 10, it'll go up to 100. Go to the start point, go to your end point, and just do your best. Again, it's a free-handed graph, guys. It's not going to be perfect. You just do your best with what you can. It's a free-handed graph. I'm not going to penalize you that hard for free-handed graphs, right? So you can see it clearly goes up over time, right? That's basically the end gist of this. I'm not going to go over the reflectant part of this here. Instead, I just want to jump into actually applying this concept at this point here. I know it's been a lot, but we're kind of jumping into it here. So starting out here, example one. Right? So example one. And I could put the page if I want, page 8. I want to actually write the question down. That's what I'm going to do. You should do that now. Pause the video, write that down. 3, 2, 1. All right. So for example one here, I'm not going to look at the solution. The solution's in your textbook. That's what it's there for. I want you to literally try and do your best to not look at it. So here's what we know. Go through it, highlight the important stuff, right? My red line here. And we're going to do fine. So Marty invested $2,500 into something with 2.5% simple interest paid annually once per year with a term of 10 years. So question A here asks, how much interest will accumulate over the term of Marty's investment? So the entire term here. Well, I have a formula for this. Interest is equal to PRT, P times R times T. Right? I'm trying to find the interest, so that stays the same. The principal, I know, is $2,500. The interest rate is 2.5%. Oh, so that's this, right? Nope, that's 25%, right? 0.025. And then it is every 10 years, over a term of 10 years. So simple enough, you just take that, you punch that in your calculator, right? 2,500 times 0.025 times 10. My interest earned is $625, right? Now, I have to reread the question again. It only wants to know what the interest is. It doesn't want to know what the full value is. So this is fine. Check. Now, question B asks us, what is the future value of his investment at its maturity? So in this case, I'm going to introduce you to a new formula. A is equal to P plus I. Well, what the heck is A? So A is the accrued amount or the investment, right? So A equals the accrued amount, or A equals the total investment after interest is added. Which is why I did is A, which is the total amount, is equal to the principal plus the interest, right? So it sounds scarier than it is. So how much money my loan is worth after it's matured is equal to the principal, how much money I put in, $2,500, plus the interest it earned, $625. It is $3,125. That is A. That is the total investment here. So it sounds scarier than it is. You just have to think about it logically, right? Now, for question C here, we're actually going to skip that. C wants us to find the investment to write an algebraic expression. We'll get to that later. We don't need to worry about that right now because it's kind of dealt with in the next application. But basically, where I can just how here, I can take any situation for question A. I can take any situation as long as I know the principal, the interest rate, and the amount of the length of the loan, I can figure out how much that loan's going to be worth. I want the same thing, but for Marty's thing. Instead, what I'm going to do is I'm going to introduce us here to the solution, right? Your textbook is used for it here. So for question C here, any loan's value can be determined using A is equal to P plus PRT. The principal plus, well, PRT, what's that? That's interest. This is the same thing as A is equal to the principal plus the interest, right? Or it's the same thing as A is equal to the principal times 1 plus RT. Um, any one of these work, okay? Any one of these work. Pick the one that works best for you. It depends on the situation. If you know the interest, you can use this one. If you don't know the interest, you can use this one. If you don't want to be asked with any of these, you can just use your brain and combine A and B together, right? So it's all doable. Whatever works for you. I don't want you to get confused with the algebra part of this. I want you to instead think about logically. You're using simple numbers here. Use it that way, right? Like, oh, if I take out a loan, I need to add the principal and the interest. It's that simple. So you can see how this plays out here. This P plus PRT thing here. So taking a look at this example here, there's someone who invested $1,500 and $15,000 in a savings account. They had an interest rate of 8%. It's paid semi-annually. And she wants to hold the investment for 4.5 years. Now, if it's paid semi-annually, I'm coming back up here. So if it's paid semi-annually, that means semi-annually is every twice a year, right? So every 6 months. So for example, I know her principal is $15,000. Her interest rate is 8% or 0.08. Same thing. I know it's a semi-annual loan. It is paid every 6 months. And I know the term is 4.5 years. If it's paid every 6 months, it's paid 4.5 years. She's going to get paid 9 times. And as you can see here, they've made a chart here to kind of introduce that to you. That a bit smaller. Make that a bit bigger. All right. So we're not going to fill this out, but instead I want to highlight how this is useful, this P plus PRT. As you can see, well, it's $1,500, $15,000 plus P R 15,000 times R 0.08 times the time, which is 4.5 years. And you can see it spits out the answer immediately. So instead of using this chart, you can see that instead you just get the answer here. So formulas are good. It is important to understand why this formula works. That's what this left chart is for. But this shows you the other information that you need as well. So make sure you get that down. I'm going to be moving on here. I have one more example I want to give you here before we keep going. So at this point, I actually want to do an example that's not in the textbook. So we're going to go example 3, not in textbook. Now, for this one here, so what interest rate would make $5,000 mature, remember, mature, end of the loan, to $8,200 over 8 years? Now, so write that down really quickly. So now with this one here, I'm not asking it for what the interest is. I want to know what the interest rate is. I know what the interest is from this, right? So you usually want to start with, what do you know? When you have a problem, what do you know? Now you might be able to look at this and be like, already, oh, I know how to solve this, but it's a useful to go through the process, right? So write down what I know. I know the principal is $5,000. I know the term T is 8 years. I know the interest is, well, $8,200 minus $5,000 is $3,200. Next thing is, what am I finding? I'm finding the interest rate as a percentage. So if I think about this, and then the third thing is, how do I do that? Well, I'm dealing with interest. Interest, I is equal to PRT. Oops. Well, so what do I have? I know that I is equal to PRT, or A is equal to P plus PRT, or I know that A is equal to P plus 1 plus RT, and so on and so forth. I know all of these things. So I have some tools I can use to figure it out. But ultimately, what I need to know here is I need to try and figure out the R. So I need to take one of these and I need to figure out what the R is. It doesn't matter which one you pick. You can do this with either of them. So what I'm going to do as my step here is, 1, write down the formula I'm choosing. In this case, I'm going to choose I is equal to PRT. Well, you don't have I. Yes, I do. I know what I is. I had to work it out from this question, but I do. Then B is I need to substitute what you know. Instead of I know that that's $3,200. I know my principal is $5,000 times my interest rate. I don't know what that is, but I do know the term is 8 years. And then C is use algebra to work backwards. Now, if after this question, you look at this and you're like, what? What did he just do? I will have a resource below this section about an algebra refresher. So if after question C here, I do this and you have no idea what I did, you need to go and look at that. You need to up your algebra. It is a 30 level math. So I need to isolate R. That means I need to get R by itself on one side of the equal sign. So I'm going to take this equation here. I'm going to start moving stuff. First thing I'm going to do, let me just quickly write that in again. You don't have to fully show all your work in this to this degree. That's something I actually haven't mentioned on. You should be showing all your work on your assignments. And, ideally that helps me help you. But anyways, I'm going to take my equation. I'm going to start getting rid of stuff. So I'm going to first start off with getting rid of this 8. You could pick, I'm just picking that number. What I really want is I just need R by itself, right? Which means I need to get rid of the 5,000 and the 8. Now I need to do, sorry, my phone's going off. The opposite of what's happening, right? So do the opposite. Do the opposite. So right now, 8 is being times. What's the opposite of times by 8? It's dividing both sides by 8. If you took the last math with me last term, you've seen this process before, right? So 3,200 divided by 8. If you're not sure, you can use your calculator. If you can do it in your head, awesome. $400, right? So I'm left with $400 here is equal to $5,000 times R. Perfect. I'm going to do the same thing now, where now I'm going to take the 5,000 and it's being times, and I'm going to get rid of that. I'm going to divide by 5,000 to both sides. I know it's not very neat. I'm dealing with a mouse. You at least have a computer or a pen. So I'm left with 400 over 1,000 is equal to R. Cool. I have 400 over 1,000. I can now simplify this to, hey, it's 2 over 5, right? So if you simplify this, you get 2 over 5, which is the exact same thing, I'm using the change button in my calculator, as 0.4 Oh, sorry, I've goofed up. Did anyone catch my mistake? My bad. It's 5,000, not 1,000. Again, even math teachers make mistakes, right? So really important we're doing this properly. So 4,000 divided by 5,000. And before I go into this, the reason I figured this out, I'm like, oh, I'm drawn here is because a 40% interest rate is absurd. It's 2 over 25, right? So 2 over 25 is equal to R, which, if converted into a decimal, is 0.08 or 8%. Remember, those are the same thing. Or 8 over 100. If your calculator, or you're not very good at if your calculator can't do this, automatically convert. And if you're wondering, how did you go from 2 to 25? Well, remember, percent. Very first thing I talked about, percent over 100. Well, I can just times these by 4. 25 times 4 is 100, right? 2 times 4 is 8. So what's my answer? 8% interest rate. So that's going to be the last example I'm actually going to do here. Now you might be looking, there are more examples in your actual textbook. I encourage you to look at these and refer to these, but they're not necessarily needed right now. So one thing I do want to go to though is this in summary page. You're going to see this in most of our chapters here. And this just really goes over like, hey, here's what you really need to know. At this point, I've rambled on for, I don't even know how long, a long time, right? In summary, here's what you need to know. So simple interest is determined only on the principal of the investment. So simple interest is only on the principal. The value of the investment that earns simple interest over time is a linear function. That's going to come into play later, but what it means by that is it means it's a basic algebra statement, right? You can graph this stuff here. The value of the investment over time, well, you can see you don't start at $0. I have to invest some money for it to grow. And then I can look at my interest over time, always starts at zero, right? If I borrow $1,000 and then I immediately pay back 3 seconds later, I haven't really taken out any interest, right? Um, you have some need to know formulas here. This is the amount of simple interest earned on an investment that can be determined using this formula. It shows what each of these things are. You can find the future value of an amount, A, right? Accrued value or total of an investment. There's two different formulas. They're the same thing here. And again, it shows you what those are. If the interest is not stated, assume it to be annual. But remember, if it's not annual, let's say, for example, it's semi-annual, so twice a month. Look at this. This money got paid out in 6 months in, and then 6 months, and then 6 months, and then 6 months, and then 6 months. We didn't really hone in on that properly before, but I do want to make a note of that. Is that if I borrow money and it's done every second, or it's done every 6 months, I need to calculate that every 6 months. If it's done every week, I would need to do week 1, week 2, week 3, week 4, week 5, and so on and so forth. So that's an important fact here. And in fact, I'm actually going to write that in here. So unless otherwise stated, interest rate is assumed to be annual, 1 times per year. If more than 1 times per year, so if it accumulates more than 1 times per year, it must be distributed, right? Be paid out at each interval. For example, weekly would be 52 times, so every week. Semi-annually would be every 6 months, as you can see in the example here, right? Quarterly would be every 3 months. So January, February, March, cha-chinga, time to get paid. April, May, June, cha-chinga, time to get paid if it's quarterly. So I hope that makes some sense. So make sure you have that in there. And again, so you can pay it out those different intervals. So what should you do now? At this point, it's up to you. You get what you put in this class. If you're not going to do any like of these, you're not going to get anywhere. So what you should be doing at this point is complete 1.1 in the textbook. Then 2 is complete 1.1 in the workbook. You don't have a physical workbook yet. Look at the file on the LMS and refer to that. Step 3 is submit the assignment. The assignment is usually going to be part of the workbook, not the whole thing. I'm going to ask for a few questions within it. This is to, 1, lower the amount of extra work you have to do, and lower the amount of lower the amount of grading I have to do. But 2, it's really just focus like, hey, here's some really necessary skills. If you choose not to do this, technically 3 is the only thing that's required. If you choose to skip 1, choose to skip 2, your grade is obviously going to suffer. You're not going to understand it as well. Your final exam is going to be based on stuff you have done. You should not get many surprises on your final. So that is very important you do this, right? You're studying while you do it. So what can you do? Stuck? First off, answers are in the back. Answers are in the back of this book. 570. Very, very back. This will be easier once you actually have a oh, sorry, not on the back of the book. They are in, let me find them. My bad. This is 1.4. Let me find it here. My bad. Here we go. The answers are in the chapter review. So you do have your answers for the textbook, but also I have included a file on the LMS that shows the answers. So long story short, you can refer to those tools, make sure you got something correct. Sorry, 1 second. So if you're stuck, check the answers in the back. 2, if wrong, review notes, try again. Usually you can work backwards from the answer. If that doesn't work, feel free to email instructor and don't just be like, I need help. What do you need help with? Tell me. Tell me what you've done. And now that just saves some time. Another thing you could do is you could, honestly, check Google, ChatGPT, other AI. AI is not great, but specifically, they can teach you the steps. They can help you figure out maybe where you got it wrong if you really cross-analyze. So it can be a helpful tool. So either way, though, if you get stuck, ask for help. I'm here. That's my job, right? So, yeah. With that, I will let you go. No, sometimes the videos will be this long, sometimes they'll be longer. I'm going to really try and make them as short as possible. This one was really an introductory one. So that said, good luck, everybody, and hopefully it goes well. And let me know if it's not, or let me know if it is.